Aloha and welcome to Week 10 of CM400C. This week, I'm going to build upon some of the concepts and terminology I discussed in Week 8 lecture, Working with Programmers. Before we dive into today's lecture, let's quickly review key concepts from last week. So this is from the Resources for Designers lecture. So if you remember, these are a few of the important points I talked about. There are wireframing web applications, so Balsamic or Go Mockingbird. I talked about the Envision prototyping web application. I briefly went over Xcode, which is Apple's IDE, where you design, prototype, and build your mobile app. And then, of course, I talked about some collaborative tools, Google Hangouts or Screen Hero. And today we're going to talk about what is a program. Think of a program as an organized list of instructions that, when executed, causes the computer to behave in a predetermined manner. Without programs, computers are pretty useless. These organized lists of instructions provided via a programming language, and when the instructions are compiled, the program runs. So what does a program contain? A program is like a recipe. It contains a list of ingredients called variables and a list of directions called statements that tell the computer what to do. The variables can represent numeric data, text, or graphical images. Why do we have programming languages? To have the computer perform some kind of computation or algorithm. Eventually, every program must be translated into a machine language that the computer can understand. This translation is performed by compilers, interpreters, and assemblers. So basically, a compiler is a program that translates human readable source code, so which is a programming language, into computer executable machine code. To do this successfully, the human readable code must comply with the syntax rules of whichever programming language it is written in. The compiler is only a program and cannot fix your program's errors for you. If you make a mistake, you have to correct the syntax or it won't compile. And you might be asking yourself, okay, what is machine code or binary code? Machine code is the name for the instructions that a CPU, central processing unit, basically the brain of the computer, can execute. It's rather difficult to read machine code as it is just numbers in memory. There are programs that can convert the numbers back into assembly language, but unless you are pretty skilled or trying to break a protection scheme, there is little use or need for it. I'm going to talk a little bit about Objective-C and basic syntax. So all programming languages have syntax. And syntax are rules for valid expressions and statements. So in Objective-C, there are semicolons, comments, so indicated by the double slash here, and then you have a if statements, and it's always, the condition is always in parentheses. You have curly braces, which in between those curly braces, that's where you have the code to be executed. Then you always have a declaration of data types and instant variables. And then you have calling methods. So in Objective-C, you create a class, and the class is always, a method is always written in these double square brackets here. And then you have a class, and then the method is always on the right-hand side. So basically, semicolons indicate the end of a statement or line of code. If you forget a semicolon at the end of your statement, you will get an error. Oftentimes, programmers will take the time to comment out their code. The reason for this is you may be working with other programmers, and it helps them to understand what is happening in the code, or remind you what the code is about. If statements is commonplace in many computer programs. We have a whole lecture on if statements. Just note that the condition you are testing for goes after the word if and in between the parentheses. The curly braces are used to declare variables. They are also used to contain all code to be implemented for a single method. And all instance variables are declared with a data type, followed by a name for that instance variable, or IVAR. So syntax, let's take a closer look. So if you see here, you'll see the semicolons, and that marks the end of a statement. And then you'll see the comments. Any comments are followed by the double slash, and the comments are in green on the screen. And then if you look for the curly braces, so if we look at that method view did load, and then you see the curly braces, that's where all the code is being written for that method. And then you have declaration of data types and instance variables. So if we look near the top, declared an instance variable called items, and it's of type NS mutable array. So, like I said, this is just to get you more familiar with working with programmers. And if you're interested in, kind of dabbling in both design and development, then this is a great introduction to the world of programming. Semantics are rules for how to organize those expressions and statements in a meaningful way to accomplish some task. Also think of it as the meaning of your code. So semantics is about whether or not the statement has a meaning. What are you trying to get done or accomplish with that line of code? So that's what semantics comes into play. The code that you write has to make sense. And here we're going to talk about just the basic structure of Objective-C. So there's your preprocessor commands, you have your interface file, you have your implementation file, you have your method, you have your variables, you have statements and expressions, and then you have comments. And I've talked about some of these in the earlier slide. So let's take a closer look. So line 1, the first line of the program, pound import foundation.h is a preprocessor command which tells an Objective-C compiler to include foundation.h file before going into the actual compilation. So line 2, at interface sample class :ns object indicates that we are in the interface part of the application. This is where we describe the class interface. Your class name is sample class here, and it inherits from NS object, which is the root of most classes in Objective-C. So line 3, dash void sample method. So this is a method declaration. And once again, a method is kind of like a function. So you're creating some functionality in your application when you write a method. Line 4, at n, marks the end of an interface file. The next line, at implementation sample class, indicates that we are now in the implementation part of the program. And once again, this is where the code is written. Line 6 shows the implementation of a method called sample method. Line 7, line of code to be executed for the method sample method. Note that the curly braces are at the beginning and the end of the line of code to be executed. And then line 8, the next line, at end, marks the end of an implementation file. Line 9, the next line, int main, parentheses, is the main function where program execution begins. And then line 10, this is another way that you can write comments. So you have backslash, asterisk, and then you write your comment, and then asterisk, backslash. Line 11, here you're allocating an instance of the sample class, right? Note that the instance variable is named sample class using camel case. Line 12, the sample method is being called by the sample class instance. So right now I'm getting really into the nitty-gritties of this file here, but like I said, if you're interested in learning more, this is a great introduction. And then line 11, the next line, return 0, terminates main function and returns the value 0. So that's the last line, line 13. So yeah, that's just taking a closer look at Objective-C program structure. What is a function? A function has a name and comes with a set of instructions or self-contained modules of code. It does a computation and returns a new piece of information depending on the parameters. So here we have two functions. I just talked about int main, and it's a function that expects an unknown number of arguments of unknown types, returns an integer representing the application software status. And then printf is another function, and it does formatted printing for you. All right, let's do a quick review. What is a program? It's an organized list of instructions that, when executed, causes the computer to behave in a predetermined manner. Without programs, computers are useless. Okay, so let's see. What does a program contain? A program is like a recipe. It contains a list of ingredients called variables and a list of directions called statements that tell the computer what to do with the variables. The variables can represent numeric data, text, or graphical images. Why do we have programming languages? To have the computer perform some kind of computation or algorithm. Eventually, every program must be translated into a machine language that the computer can understand. This translation is performed by compilers, interpreters, and assemblers. Two components of a programming language. There's semantics and syntax. Syntax could be anything like the double slash to write comments, or the semicolon, which closes a statement. And then semantics is really making sense of what you're asking the computer to do. And then you have Objective-C program structure. You have the preprocessor commands. You have the interface, the implementation. You have methods, variables, statements and expressions, and then of course you can leave a comment. And then lastly, what is a function? A function has a name and comes with a set of instructions or self-contained modules of code. It does a computation and returns a new piece of information depending on the parameters. So that's it for this week's lecture. I hope you got pretty excited about learning a little bit more about coding and development and what is a program. Next week, we're going to go straight back into learning a little bit more about Xcode and, of course, prototyping using the storyboard. Have a great week.